Okay. Let's do integration by parts, guys. So we are on page, what page are we on? 108. 108. My favorite number. But, okay, integration by parts is basically reverse product rule. Okay, so you've already done U sub, which is reverse chain rule. Integration by parts just undoes product rule, right? So that's when you have like a function that you want to integrate that's x e to the x, so it's something times another function, x sine x, you can't integrate normally. If this was sine x squared, then you could just do normal U sub, right? And this is x, natural log x. So all of these, you can't integrate normally. So what you have to do is integration by parts. But this is where integration by parts comes from. So we're going to start with just doing normal product rule. If I take the derivative of uv, then I'm going to have u dv, right? U times the derivative of v plus v times the derivative of u, right? Does that make sense to everybody? Okay, if you integrate both sides, so if I integrate this side and I integrate all of this, then what happens to the integral of the derivative? It just cancels out, right? And then I'm taking the integral of all of this, so this becomes integral of u dv. And then I'm just going to split up the integral across addition and say plus the integral of v du. Okay? Everybody okay with that? All right, so we're going to rearrange it a little bit, and I'm going to solve for one of these integrals. It doesn't matter which one you solve for, but usually we solve for this first one right here, u dv. Okay? So if I solve for that, then my integral is integral of u dv equals, what does it equal? U times v, right? And then what? Minus, thank you. Integral v du, right? And then you say, well, this doesn't make any sense at all. All we did is rewrite product rule, right? But it works. So we do this integration by parts. We're going to use this formula for this x sine x, all right? So if we have the integral of x sine x, then I am going to make x my u, and I'm going to make sine x dx my dv part, okay? So that's basically the same as this integral u dv, right? All right, so we're going to say u equals x dv equals sine x. All right, technically it has a dx here, right? But you don't need it if you don't want to. Okay, what's the other components of this formula that I need? I have u, so the only other things that I need, and I have dv. That doesn't help me at all, right? I need v and I need du. So I'm going to find both of these. If I know u equals x, what is my du? 1 dx, right? And if my dv is sine x, then what is v equal? Good. Okay. We don't need the plus c because we'll take care of it later. All right, so this integral is going to equal the expression u v minus integral v du. So we know that u is x. We know that v is negative cosine x. Sometimes I draw this. So x times negative cosine x. This is how I remember it, so that if it's in chart form, I go from u to v, I go diagonally across, and then I say minus, and then I say this is minus the integral going back of v du. So if you remember this direction, then you don't have to remember the formula because it goes u times v minus integral of v du. That's helpful. Okay, so the integral of v is negative cosine, and du is 1 dx. Okay, and then you just simplify by integrating this. So what's the integral of negative cosine? Negative sine. So this is going to simplify to negative x cosine x plus sine x, and then we can just tack on a plus c at the very end, yeah, because we didn't do a definite integral. Okay, that's the integral of x sine x. If you want to prove it, let's take the derivative of x, derive x, negative x cosine x plus sine x. And so if I do that, I have to do product rule. So this would be negative x times the derivative of cosine is negative sine plus negative 1 times cosine x, right? And then the derivative of sine is cosine x. And so I have a negative cosine x plus cosine x, that cancels, and the negative times the negative is x sine x. So that proves that the derivative of this is that, right? You don't need to do the proof. It's just showing you that integration by parts works. Oops. Okay. All right. Common thing you want to do is put u as, the first thing you always want to do is you want to try to make u, here's helpful hints, try to make u something that gets smaller. Something that gets smaller. So does the 5x get smaller or the e to the 3x? When you derive it, 5x gets smaller, right? 5x goes to 5 and then it goes to 0, right? So that's why we want to make u 5x. So u equals 5x. Then we're going to make dv e to the 3x. Okay? Now I want you to try the rest. Now you have to find du and v. So you have to take the derivative of this side and you have to integrate that side. And remember, the arrows that I drew are super helpful when you're doing integration by parts. And I'll help if you need. No, because it could be in the other order, and so it would. You could have to choose the thing that reduces when you, for you. You want it to reduce.
When you derive it. Right?
When you derive it, yeah.
What if both reduce and maybe just to guess?
If both reduce, then you wouldn't do integration by parts.
Oh,
Because if it was 5x and like x squared, both of them reduce, but you could just multiply 5x and x squared together. Like there's you're gonna get to integration by parts for when you have a function that doesn't.
so it'll be like a normal function
And then like it's a transcendental function is what it's called.
Okay.
And transcendental functions are d's, logs, sines, like trig functions. Yeah.
Okay.
Yeah.
And so like if it was like 5x squared over x, like even that would just multiply.
Yeah, you just make it 5x over x, which is just 5. You
Yeah.
just integrate, right?
Okay, yeah.
Yeah, it would be, it's always some, either two transcendental functions, which we'll get to in a minute, or just one transcendental function, and then,
If it's two transcendental functions, then is it guess and check?
no, then we'll do it.
Oh.
It's integration by parts still, but, yeah,
No, but like for picking which one's like you.
we'll get to it. Yeah. It doesn't matter is the answer,
Uh-huh.
but I'll show you what you'll have to do.
Okay.
Okay. All right. So this is 5, and this is 1/3 e to the 3x, right? And then I don't know about you, but I like drawing from u to v, and then integrating minus the integral here. So that helps me figure out that it's 5x over 3, or you could say 1/3 times 5x, e to the 3x, minus the integral of 5/3 e to the 3x dx. Okay, and then I still need to integrate that other part. So it becomes 5/9, right? E to the 3x and then plus c. How'd you do? Good? All right, nice. Now, try the next one. Scroll up a bit. Yes. Did you get it, Aika?
Yeah, we absolutely found derivative of t.
Oh, yeah, that's an easy mistake because you're having to derive and integrate at the same time. It's weird that it like, yeah. Okay, you almost always want to get equal to something where when you take the derivative of it, it ends up going to 0. So the 5x, your first derivative so it's so that's what you have to do. And then the d plus this integration exports you can make other functions like. There's going to be times where that doesn't happen. I don't think those. But I'll tell you what it is. Okay. But it's almost always the if you have a polynomial. Yeah.
So I think this as to why this one was 5x as per and how to actually compare the sections and small.
Well, the one that's going to get smaller when you take the derivative. E to the x when you take the derivative is always going to stay e to the x, so it's not going to get smaller, so you don't want to do u. Okay. But the x squared when you take the derivative is going to be 2x, right? And that's going to get smaller as you go down. So make you with something think that when you take the derivative, if you do it a whole bunch of times, it's a substitute. So you're there you go, Andrew.
Yeah.
me know if you need any more help after that. Okay. Did you do it? I think you had to do it twice.
There's also a plus C, don't check the plus C. Get back there. Well, he's still practicing. It's part of the process.
Okay. Nice job. I think you have to do 2 integration by parts for this one. Andrew, did you get it down? Okay.
Oh, you already started it? Wait, see? I haven't even started it.
We're not supposed to do this.
I don't know why they chose U's and V's for this. They look so yeah, they look so similar.
So like we're doing this nesting unit, so all 4 that one.
Oh.
Those time estimates are ridiculous. Like they need to do it.
It's like 3 hours of like
Okay, check your answer with the one I wrote up. See if you got the same thing.
That's a little suspect.
Next page.
All right. Now, if you had to do 5 of these, that would really suck, right?
Yeah.
Okay. Do you notice that the first one's positive, right? It's UV. And then the second one is negative, right? Yes. And then the third one, if you put it inside, it would be a positive, right? And then if you put a fourth one inside, it would be a negative. So it would change signs every time. Jordan?
Why is it negative the second time?
The second time, because it's UV minus integral V du. Oh, did you put plus?
I think I did that like the entire way through.
Oh. Just change your pluses to a minus. Anyways, so the first one's a second one is a minus, and the third one will be a plus, and then the fourth one would be a minus, right? So there's a faster way. You don't have to do it this way. If you like to do it this way, then just set it up this way. But there's a faster way to do the repeated ones, and actually you can do it for all integration by parts ones. It's the table. Tabular approach. Okay? So, here's how you do it for the tabular one. You still have U, but instead you make it a column, and then you have dV, but you also make that a column. All right? So we make U still x squared, And then dv, we're going to make e to the x. All right? And we're going to still take the derivative on this side, and we're going to still integrate on this side. So the derivative of u is 2x, right? And the integral of dv is e to the x. And then the derivative of 2x is 2. And the derivative of e to the x is e to the x. And then the derivative of 2 is 0. And the derivative of e to the x is e to the x. Now you stop here. Stop at 0. When your u equals 0, you're going to stop at 0. And then all you have to do now is go, remember how we said it was alternating? So you go plus, minus, plus. And so your answer is x squared e to the x minus 2x e to the x plus 2e to the x plus c. And it's the same as the answer on the previous page. It's the same way. Yeah, you can do it either way. But you had to know that, well, you had to know the formula. You had to know why you were doing it before. Because it doesn't always, it works all the time, but you still, sometimes, we're going to get to a point where sometimes it doesn't equal 0. So I need you to know the other way, so that if it doesn't get to 0, you'll know what to do. Okay. So, try the next one. Don't do this one yet. We'll talk about this one in a minute. But you can do whichever one you want to for this one. But if you do it by the first way, you're going to have to do 3 of them.
You're saying that you shouldn't do this when this doesn't go to 0?
You can do it when it equals 0, but I'm not sure how to show you
The different way, right?
how to finish it. Yeah, when it doesn't equal 0, I have to show you how to finish it. Yeah, you can do it on the AP exam, it's totally fine. And they'll take it, yeah. Okay, so you always make u the thing that gets to 0, if you can. Sometimes you can't. I feel like sometimes integration by parts is kind of soothing.
Yeah.
Oh, guys, sorry. I don't think it works for this one. Sorry, can you erase? My bad. I thought I was going to give you one to practice, but you can't practice. Let's do this one together. Yeah, exactly. Because I think a lot of you are coming up with, I can't integrate e to the x squared, right?
Yeah. You can't, right?
You can't, right?
Okay, good.
But you can it how? But then what's du? 2x. So what do I need on the outside? Right? I need an x at least on the outside. I don't need a 2, but I need an x. Anwar, you got an idea? Yes, exactly. You can just split it. So you can make this one x squared and move one of the x's over. You see? Everybody get it? So in total, this whole row equals this whole thing, right? Because you can't integrate it if it doesn't have an x. E to the x squared. Right? Okay. So now we can take the derivative and we can integrate this. This becomes, what does it become? Yeah, and this is where your integration skills will come into. Hopefully you can do that in your head. Because if u is x squared, then du is 2x, but I don't have a 2, but I have the x, so the
does
one
it stop right there though?
No,
You give the x again.
exactly. So now at this point, listen guys, now at this point, you need to draw a dotted line. Yeah, so when we draw a dotted line, what happens here is that, again, I need an x on this side in order to integrate e to the x squared, right? So this row, I'm going to rewrite down here. So this is not an equal sign right here. I just am moving things from this column to this column. So I am going to move the 1/2 over to the u side and make it 1. And I'm going to move the x over to the e to the x side and make it x e to the x squared.
Why did you move the 1/2? Which makes it easier.
Oh, yeah.
So we could have kept it.
No. Yeah, TJ, that's the thing is you don't want to multiply it over. It's just moving it straight over. Okay?
Do you have to move the
You don't have to move the 1/2. Yeah, you could leave this as 1/2 x e to the x squared. I think it just it makes it easier. Okay.
Why didn't you just make the first move x and then
Because you can't integrate x e to the x squared. X squared e to the x squared. Okay. All right, so now here, my derivative of 1 is 0, which is good. I got to 0. And the integral of this, I already did once. So I don't need to think about it again. All right, the reason why you drew this dotted line was because these two rows are equivalent, so you don't want to cross the dotted line. You just want to, when you draw your arrows, it's just from here to here, plus, and then from here to here, minus. So it's x squared over 2 e to the x squared minus 1/2 e to the x squared plus c. All right. Yeah, Michael.
It would just be e to the x squared because it's 2, like, between pieces is 2x.
No, because the e to the if you make x squared equal to u, and du is 2x, so we need to
Okay.
Are you talking about integrating x e to the x squared?
Yeah.
Because
Well, like, so
Any questions?
if it's this integral, you don't.
Okay, let's,
So what I think.
yeah.
The dotted line you just slide over.
Yeah, you're just reassociating it, so this line and this line are equivalent. If I multiply this line together and I multiply this line together, they have to equal the same thing. The products are the same, yeah.
So basically, like,
Yeah.
you had it it's like this.
All right?
So
All right. Yes. No, you don't. You can leave the coefficient on whatever side you want to. If it makes, I always like to move it over to this side because it makes it easier to draw. But you don't have to. Good questions, though. All right.
integrating that.
Now, Rachel. You have a question? Okay, sure. So if u equals x squared, right?
Oh, are we just doing this?
I don't know. I'm this question.
No, this to integrate, are you talking to go from here to here? Since you have e to the x squared is inside of your exponential function. So u is x squared, and then du is 2x. Well, the x I have here, but I still have the 2. So that's why it becomes
So you just
1/2.
say u-sub.
It's normal u-sub, but I did it in, you want to try to do it in your head because it gets super confusing if you don't. Yeah.
Alright, and then I also wanted to ask again why we couldn't just integrate the way it was before, meaning like
Which one?
U being x cubed and then d being x to the.
But you can't integrate e to the x squared.
Why not?
Because x squared is inside of e. So I can't say, if I have u as x squared, I don't know du is 2x and I can't integrate that. Well, because I don't have the x to get rid of.
Okay.
Okay? Right? So if you're doing u sub, if you have a function inside, you have to have the, if it's x squared, I need to have an x on the outside. If it's an x cubed inside, I need to have an x squared on the outside. Right? So if it's inside and your du has an x in it, then you have to have it somewhere in the rest of the function. Okay, now here's the only tricky part, is when you don't know the integral of something. Because you don't know how to integrate natural log x, right? All right, so, no. If you don't know the integral, no, it doesn't, it does exist, but you must make that part u, okay? Okay? So if you don't know the integral, you have to make that part u. There's only two rules. The first rule is try to make u something that reduces, and the second rule is if you don't know the integral of it, that has to be your u because you can derive it, but you don't know the integral of it.
So this time we can't do it.
Yeah, now our dv is going to be x squared, and you're going to help me through this. So there's only way that one way that I can do this because I don't know the integral of u, but I do know how to take the derivative of u. So u is natural log x. Let's go to what's the derivative of natural log x?
Would the integral of natural log x be x times natural log x minus 1? Because
xl and x minus x. dv, what's the integral of x squared? So 1/3 x cubed. So now I'm never going to get to 0 on this one, right? So now I want to do my rewrite thing. Okay? Now I'm going to move the 1/3 over to this side because it's easiest that way. And I'm going to move the x over to this side. So what does that make this side? Not x to the 4th. X squared, right. Because you're not multiplying it over, it's just moving straight over, so it's becoming x cubed over x. All right, now what's the derivative of 1/3? What's the integral of x squared? And then you can draw your lines, plus, minus, and you're done. So it's natural log x, 1/3, x cubed. Oh, I don't like that. 1/3 x cubed, natural log x, minus 1/9 x cubed. Let's see. Yeah. And then there's only one more weirdo one. This is, Arian, this is the one that I was talking about. Where you have two transcendental functions and neither of them reduce, right? So, when you have two transcendental functions and neither of them reduce, you still do u and dv. Actually, I'm going to do it over here. Just to give myself some equal space. All right, so you make, it doesn't matter which one, you just choose one side for one and the other side for the other. So I just did it this way because I like taking the derivative of trig functions better than I like integrating trig functions. But you can do it whatever way your heart desires. Okay, so this becomes -4 sine 4x, right? And this side becomes 1/6 e to the 6x. And then this side becomes -16 cosine 4x. And this side becomes 1/36 e to the 6x. Okay, now, if we kept doing this, we would go on forever, right? So, that would be ridiculous. You stop when you get to the original two functions that you started with, ignoring the coefficients. So once you get cosine 4x and e to the 6x back, those two functions back, then you stop your table. Okay? And so now we're going to go, same as we did before, plus, minus. But since I didn't get to 0, I have to do this. I have to go back. And what happens when I have to go back? I still need to integrate, right? So integral, and this is a positive. Okay, so positive integral. That's a plus integral.
When you make the original
The original two functions reappear in your trig table. Okay? All right, now follow me. This is equal to 1/6 cosine 4x e to the 6x. This becomes plus, because it's negative times a negative, 1/9, right? Sine x, or sine 4x e to the 6x. And then it's plus, and then this is a minus, and that's a positive, so minus 16/36 simplifies to 4/9 integral cosine 4x e to the 6x dx, right? Yeah? Okay. Now. Yeah, we're back where we started. This, right? And this are the same thing, right? Are you with me? Well, no, I accidentally highlighted that part. But this integral is the same thing as that integral, right? So what we do is we say, oh, let's take this and add it to this side. Then I have 13/9 integral e to the 6x cosine 4x dx equals the rest of this. Are you with me? Because this is just 1.
You add the yellow part.
Yeah, this is just 1. And then I added this over. So 9/9 plus 4/9 gives me 13/9 of this integral. Right? So now how do I solve for this integral?
Multiply by 9.
Just multiply by 9/13. And then add a c. And then that's your integral. Kind of interesting. You don't like it? I like it. I think it's really cool.
I don't like it.
It's so cool.
This is just gonna take like a week.
No, it's so cool.
It's like an infinite series. You just keep plugging it back in.
Yeah, until you get to -1/12, right?
Yeah.
All right. Try this last problem with the bounds on your integral and tell me what you get. And then I want you to do some practice problems. You can just use a scrap sheet of paper, or there's a paper up here if you want to grab a piece of paper up here and use one of these. That's fine. Huh? No, do this one, and then I'm going to put up some problems I want you to practice.
Use trig properties to make.
Oh yeah, don't use trig properties.
You got a little scared there. Really?